Now let's talk about ultrasonic wave production. We all know what is ultrasonic wave, how the ultrasonic wave is inaudible to human being, right? Ultrasonic wave is basically those waves which fall under the category of frequency greater than 20,000 Hz. All the waves or all the sound waves which have frequency or wavelength frequency which is greater than 20,000 Hz are termed as ultrasonic wave. Now, after knowing characteristics and properties of ultrasonic wave, it becomes quite important for us to understand how these waves are produced, right? Naturally, it is produced and we cannot sense it, but we can produce this particular ultrasonic wave using some equipment. So these ultrasonic waves are produced using mechanical generator or electrical generator. So when we talk about producing ultrasonic wave, we have two different categories. Either we can produce it mechanically or we can produce it electrically, right? So there is a mechanical generator and there is an electrical generator. Our focus area is electrical generator, how we can produce using electrical generator and ultrasonic wave. So there is again two different devices. One is magnetostriction generator or oscillator, right? There is a magnetostriction generator or oscillator, and there is another category which is piezoelectric generator or oscillator. So one by one we will see how these two different devices help us to generate ultrasonic wave. So let's just see now. Let us first talk about magnetostriction method. First, talking about principle, on which principle this particular equipment works. So the general principle which is involved in generating ultrasonic wave is causing some dense material to vibrate very rapidly. When few dense material or when dense material vibrate very rapidly, then there will be a generation of ultrasonic wave, right? The vibrations so produced by this particular material then cause the air surrounding that material to begin vibrate, right? And this vibrating with the same frequency as that of the particles or dense particle. The dense particle vibrate with whatever frequency, the air surrounding dense particle will also vibrate with the same frequency. And this vibration then spread out in the form of ultrasonic waves, right? So this is how we generate ultrasonic wave using magnetostriction method. So this is the basic principle which we use to generate ultrasonic wave using magnetostriction. Now, when a magnetic field is applied parallel to the length of ferromagnetic rod made to materials such as iron or nickel, right? We are taking any ferromagnetic material. It can be iron, it can be nickel. Generally, we take either iron or nickel. The more preferred one will be iron, right? So it is quite easy to obtain iron rod. So first preference is always iron, then we go ahead with nickel rod. So when a magnetic field will be applied parallel to the length of ferromagnetic rod, right? Means when we apply magnetic field parallel to either iron rod or nickel rod, a small elongation or contraction will occur in its length. This change in dimension of the rod is termed as magnetostriction, right? This termed as magnetostriction, change in length due to magnet. Magnetostriction, as you can see this word, we can divide this word in two parts, magnet and restriction, right? Restriction is made up from restriction. So when there is a change in length, whether it is elongation or contraction, it is termed as magnetostriction. Now, the change in length basically depends on the intensity of applied magnetic field. How much and what intensity of magnetic field is applied will predict the length of contraction or expansion in that particular rod, right? And also the nature of ferromagnetic material. What is the inbuilt nature of material which you are using is also responsible for amount of either expansion or contraction in that particular rod. Now the change in length is independent of the direction of electric of that particular field, right? So the change in length can be in any direction independent of the direction of field. Here you can see this particular picture. This is basically a sketch diagram of magnetostriction method. Now we know the principle, we know how we are going to perform this particular application. Now let us see what are major components which will be used here. So the major component which we are going to use for production of ultrasonic wave using magnetostriction method is LC oscillator, transistor or triode to make oscillator circuit complete, and LC oscillator is tuned to match with the natural frequency of the magnetostrictive vibration of the rod given dimensions, right? So these are the two devices, LC oscillator and transistor or triode, which will complete the circuit of this particular device, right? So these are the two basic requirement for this thing. Now let us just see. So the rod will be permanently magnetized in the beginning by passing current, right? So once we pass direct current, the rod will be permanently magnetized in starting. Then the battery will be switched on and hence current is produced in the transmitter. Since we are passing current over there, so it will be produced in transistor as well. Now this current is passed through the coil L. That coil L will be having this current will be passing through that, which causes a corresponding change in the magnetization of that rod. Now the rod will start vibrating due to this magnetostriction effect, right? So once you pass the current and you start this particular field, it will start vibrating due to effect of magnetism. When a coil is wounded over a vibrating rod, then EMF will be induced in the coil called as converse magnetostriction effect. Due to this EMF induced in the coil L1, the induced EMF is fed to the base of the transistor, which act as a feedback, right? It will act as a feedback, which will a continuous process. Now in this way, the current in the transistor is built up and vibration of the rod is maintained continuously. The frequency of the oscillatory circuit is then adjusted and the condenser C, and when this frequency is equal to frequency of vibrating rod, resonance will occur. So 1 by 2 pi under root of LC, you can see here, this is equivalent to nothing but 1 upon 2 L under root of E by rho. So L is length of rod here, E is Young's modulus of the given material which forms the rod, and rho will be the density of material of which the rod has been made. So this is how we are going to perform this particular experiment, right, or this particular production method to determine or to obtain or produce ultrasonic waves. Now talking about merits and limitations of ultrasonic waves. So what are basically merits and what are demerits or limitations of ultrasonic of production of this method for ultrasonic wave, right? So when we produce ultrasonic wave using magnetostriction method, what can be merits and limitations? So first and foremost important advantage of using this method is magnetostrictive material which we are using, that is iron or nickel, are easily available and they are inexpensive. So this is a biggest advantage because cost plays very important role. Then the oscillatory circuit is quite simple to construct, right? So it is very much simpler to construct that circuit as compared to any other method. And third is the large output power can also be generated using this particular method. Once we know advantages of using this method, let us just see what can be the drawback or limitations of this method. So it can only produce frequency up to 3 megahertz, right? 3 MHz, that is 3 megahertz is the only frequency up to which this particular equipment or method can work and can give you ultrasonic wave. Then comes, it is not possible to get a constant single frequency because rod depends on temperature and degree of magnetization. So this is very important, we must remember this point. Single frequency is not possible in magnetostriction, and this is just due to two important factors: rod temperature and degree of magnetization. And third one is, as the frequency is inversely proportional to length of vibration, so the increase of frequency, the length of rod should be decreased, which is practically impossible, right? We cannot decrease the length of rod beyond certain limit. So this is a biggest disadvantage for this particular method. Thank you.